Yeah, so hi everyone. This is a talk about reproducible and transparent data journalism with modern tools. My name is Stefan Wehrmeyer, and I'm a data journalist from Berlin. I work with Correctiv, which is a non-profit investigative journalism newsroom in Berlin and Germany as a whole. Oh yeah, I shouldn't forget. I brought flyers and stickers. And I want to open this with an anecdote about reproducible and transparent journalism. This is an article by 538. You see it here on the left. It's an article that is about the Bechdel test. And if the Bechdel test, who knows what the Bechdel test is? The Bechdel test basically tests if a movie is feminist of some sort. For example, the Bechdel test means the movie has to pass the following criteria. There are at least two women in the movie who talk to each other about something else than a man. So if that happens in a movie, it passes the Bechdel test. And surprisingly, a lot of movies don't pass the test, especially like Hollywood movies. Women are only there for decoration, let's say. Is the sound okay? Because it's, again, I'm getting a bit of a feedback here. All right, and so 538 wrote this article where they took the movies and how much money the movie made and if it passed the Bechdel test and if there's a correlation. So if you can say, if your movie passes the Bechdel test, if there are women and they have like significant roles, they talk to each other about something else than a man, then the movie makes more money in the box office. So is that true? And so they took the data about Bechdel tests. There's actually a website that ranks every movie according to the Bechdel test. And took box office data and then wrote this article where basically this graph was one of the conclusions. Dollars earned for every dollar spent for movies that pass the Bechdel test and movies that don't pass it, basically. And that was actually a nice article. 538 is known for using data to explain stories and circumstances. They pride themselves into using data. But someone was not happy, and someone was called Brian Keegan, and he wrote this very long article called "The Need for Openness in Data Journalism." And he criticized that the article that you see here on the left, it's about that size, some graphs, it explains what they did, more or less. It explains where they got the data from, it explains what they did with it, but it explained it in prose. It explained it with text, they described it for the readers. And what Brian Keegan did is he wanted a reproducible version of that. He wanted to get to his own conclusions, and so he tried to reproduce the investigation that they did in a notebook that is here on your right. And it is a bit longer, actually. So he really went into detail and really tried to find out what's behind the data, tried to come to the same conclusion, and he couldn't quite reproduce it because every time you work with data, you have some assumptions. You interpret this fact as such, or this column must mean that, and this is not the same as someone else might do it. And this leads to different conclusions. And if you don't have your data analysis in a reproducible format, you might disagree in the end, because the methodology that 538 used couldn't be reproduced. It was just prose. It was not what the computer could understand, what you can reproduce for yourself. And so if you're not transparent about your data story, someone else might make you transparent. Someone else might write this very, very long article and prove that you have maybe not done the right thing here and there and there. And that's the need for transparency in data journalism. There are a couple of points in there. The first one might be data is usually seen as truth. So if you say, yeah, but I have data to prove it, everyone says, okay, we got data, it's fine now. The problem is many people trust the computer and trust data. They see it written in a table, they see what the computer says, and they believe it. And that doesn't mean they understand it. It's actually probably why they believe it, because they don't understand it. Because computers are still, for many people, a bit of a complex thing, especially working with data, understanding data. And so they believe it because it's data, and that is basically wrong. You know, it's not what you should do. And if you're more transparent about how you work, when you explain how you work, you make it understandable how you work, and then also your readers might understand. That's one of the points. The other one might be that data sets are now too big to fact check every data point. So you have a data set that has, like, let's say, 1 million rows. You can't go to every row and fact check it, like try to find out if that value in that row is really correct. So if you're transparent about the source of your data and the processing, you boost the credibility in your data. You can't fact check everything, but at least you can show how you worked. And it shows that you have good faith. You did a good faith approach to your story and to your investigation. And the problem is also data always allows for multiple interpretations. You take a data set and you might come to that conclusion, and someone else might take a different angle, come to a different conclusion. The best example for that is the Simpsons Paradox. It's actually nothing to do with the Simpsons, though. The Simpsons Paradox is named after a statistician called Edward Simpson, and it's about basically it can be explained by a study of gender bias among graduate school admissions to the University of California in 1973. So you see here, there are applicants and admitted applicants, and there's a split up by men and women. And the question was, is there a bias? And there was actually also, I think, a lawsuit about it. And what do you think happened here? Is there a bias towards men? Look at the data. So there's basically 8,442 men who applied, and 44% got in. And there are 4,321 women, and only 35% got in. So it looks like there's a bias towards, letting more men in and keeping women out of graduate school. But when you look at the data at a more granular level, here it is split up again by department. You can see the departments, that every department there is a higher, so almost every department there's a higher admission rate among women, sometimes actually to a very high degree. And this is the same data set. There's no trick in there. It's just a different way of looking at it. And so this could be one story, and this is a complete opposite story. And only if you make your data work transparent, you can really make your readers understand what the data is like. And two opposite stories, and you better basically give readers access to the whole story, and that means also the raw data. So what's the difference between transparent journalism and reproducible journalism? I'm trying to think of it as like someone gives you a manual about juggling. Here, this is how you juggle. And he gives you like a couple of balls. So it's basically the methodology in written form, like as a prose text, the manual, and the data, like some juggling balls. And then you're expected to juggle. But you don't know how to juggle. You have the balls, you have the manual, but there's no juggling going on. And reproducible journalism is basically someone taking your hands and moving them in the right way, and then suddenly you're juggling. You may not understand what you're doing, but in the end, it's basically you get the gist of it, and then slowly you get the rhythm, and then you know how to juggle. That's basically like a short metaphor for it. Of course, reproducible journalism has risks. Others can expose flaws in your methodology. So if you write down exactly what you did, someone else can look at it and say, oh, but you did something wrong, and now your whole story is wrong. The benefit is you can learn from it, right? If you don't open up your methodology, you will never know that there was a flaw. You think your story was completely right, and maybe through some other thing is exposed as wrong. But if you open up your data in the beginning, you maybe also share it with your colleagues or other people in your community, you can find flaws early. So you're more open, but that means also you're a bit more vulnerable. But the benefit is you learn from your mistakes. And there are, of course, the big ones actually that why also at Correctiv, we're doing reproducible data journalism. The first thing is automation. When you automate things, when you write it down in code instead of prose, so when you describe how you transform data with code, you can automate it. You know, the computer can do the work, you don't have to do it any longer. And so you can focus on what really matters. And when you get the same data or an updated data set in a year, you can apply the same steps, and it's reproducible and you don't have to do the same work again. And of course, it's documentation of your own work, because the next year you want to adjust something and you don't know you don't have no clue how you like updated that Excel sheet, and you have no clue how to do it anymore. And so, but with a reproducible way, you can just apply the same steps and also look at what you've done before, and it's very transparent. So these are the levels of reproducibility I see. So the first one is describing the results, so basically just in prose. It's basically only just describing your outcome. So I found that that there's a bias against women. The second one would be describing the methodology. I used this data and I applied this transformation, did this analysis, but only in text form. Then it's providing data. I use this data set, which is actually quite helpful when you want to reproduce something. Then it's like providing a machine-readable methodology, so you can actually run the same analysis on your computer. And then there's providing a computational environment for it, because sometimes it's, especially with complex analysis, it's difficult to set the environment that you used for your analysis up for others, so it's difficult to transfer this knowledge to someone else. But if you provide like a ready-made environment that someone else can use for this, it's much easier. So this was very theoretical, I guess. Here are like some more practical ways of approaching this, and actually how it looks like. So here are some tools that support reproducibility. And so what does that mean in practice? So anywhere where the steps that you use to transform data, when they can be reapplied to the same or another data set at a later stage. And so to say it in a fancy word, is basically you formalize your work into an algorithm. Whatever you do, you basically formalize into an algorithm, so you write down what you do, and then let the computer do it. So you don't have to do it yourself. So OpenRefine is an example that has reproducibility in it. I will show it in a demo. Then, of course, programming is basically reproducibility. It's scripts with Python, R, Ruby. Makefiles are also a very good way to do reproducibility. And there are things that make it easier to understand, easier to approach, and also better to document, like RStudio, R Markdown, and Jupyter notebooks. But for example, Excel or Google Sheets, which are basically the normal ways to process data, have flaws. So Excel is very good at hiding things. So you do a formula, and then it takes this cell from there, and then you sustain the value. So you delete the formula, but keep the value that it has computed, and then you move that column around, and then you delete that row. And the only way to reproduce that is going like Control Z, so doing a undo, and then a redo, and this is basically the reproducibility. But as soon as you close the application, you've lost basically the steps in between. And there is actually also a famous anecdote about this. There was an economics paper called Growth in a Time of Debt by Reinhardt and Rogoff. I don't know if some of you know that. It was a study that tried to show that when a country goes into debt, it basically it also fails economically. And this has been shown that these economists, Reinhardt and Rogoff, they made a couple of mistakes in their Excel sheet, and that turns out that it changed the result, or at least the conclusion of that study. And in the end, they didn't have to quite retract it, I think, but it basically shows you what kind of mistakes you can make with Excel without actually realizing. They basically selected the wrong range or dropped out some other values. And this is something that you can't immediately see. And it makes it, because when you look at the spreadsheet, you just see a table and not how the table came together. And this makes it very difficult to see what has happened. All right, now I'm going to do some demo and interactive part. So some of you have laptops. Do you also have internet here? Is that like a yes for internet? Yeah, some internet, all right. Let me actually give you a couple of demo things. That's not it. That's it. So this is Google Refine. And this is how it looks like. I don't know if you've seen before. It's basically an application that allows you to load CSV files or other tabular files and then transform them. For example, here I have states in Germany and a population by date in columns. But as a data journalist knows, your data shouldn't grow in columns, it should grow in rows. Because it's easier to work when the data is in rows. So you can actually you can apply things here, like can transpose these cells, these columns into rows. And I've already done that, actually. So I can, here's like an undo redo thing, and I can basically redo the step here. And then I basically put the year into this column, the population in this column, and then I have the states here. But then I see, okay, here now a lot of empty cells for the state, but I can reapply the step for filling it down, and then I can also reapply another step, so only have the year and no longer the date here, the 31st of December, because that is a bit irrelevant. And now I have like a data set that is much more like easier to work with. And I can undo it, I can redo it, and I can also extract the whole thing. So this is like the machine-readable version of these operations. And I can take an operation here and give it to a friend, and he applies it to the same data set, and then he or she can do the same thing. And if I have an updated data set, if there's like a new year, like the year 2014, I can load the same data in and apply these steps, and then I have saved a lot of work. So I don't have to load a data set into Excel and do that thing manually. I can recreate these steps here in a reproducible manner. But that is currently, I use Google Refine mostly for these easy tasks, but when it gets more complicated, I'm using Jupyter notebooks with like pandas as a data analysis library. And so anyone who has a laptop here, I encourage you to go to this address, try.jupyter.org. Oh, I'm going to wait a second. So what Jupyter is an environment that runs in the browser that provides you with a web interface to interact with a programming language in the background. And you can create these notebooks, as they are called, and they basically are prose interleaved with code and the result of code execution. And how that looks like, I will demonstrate right now. So when you have loaded that page, it should look like something like this. And you can click on New, and then you can choose, for example, Python 3 as a, oh, great. I think I should reload that page. Yeah, okay, let me reload that page. I hope I still have Wi-Fi. Perfect. So you see this again, and now I can click Python 3. And I end up in this thing. And here there are already libraries installed that are useful for data analysis. So this is now an example. It's like import pandas as PD. Can you read that? Yeah, perfect. And this will import the pandas library. And I've chosen a data set today to work with. It's called The Origins of the Super Rich, the Billionaire Characteristics Database. You know, in the wake of the Panama Papers, maybe talking about billionaires and analyzing how they came about is maybe interesting. So this imported the pandas library, and this thing here is called a cell. It's basically like you stack cells on top of each other. When I click plus, I get another cell below it, and the cells can be of certain types, and I can change the type, for example, to Markdown, which allows me to write, for example, here I write the title of our data set in here, and then I have basically, I can document what I'm doing, an analysis of this data set. And so let's load that data set in. I already prepared something, so if you want to follow up, it's here. You have to type PD for pandas, the data analysis library, .read Excel, and I already put the data at bit.ly/International Journalism Festival, so IJF-DDJ, I think, and I assign that result to a variable called df. Usually it's a data frame, that's just a convention that is usually used. Can have any other name. And let's see. Okay, that didn't work. Oh, great, they don't have that. They don't have that. Okay, perfect. Yeah, sorry, that didn't work. Oh, God. So if you go there, you can download it and open it up. And this is how it looks like in Excel, or in LibreOffice in that case. It's basically a list of all billionaires at certain stages. So they did like a survey in 1996, 2001, and 2014, and they basically recorded who was there as a billionaire. And so let me actually try to quickly save that as a CSV file and make it available to you. Let me put it into this one. Yes. Okay. And here there's some variable description, which is also nice. It explains what it is, what the columns mean. But if I want to do any kind of analysis in here, I would probably create new sheets. But if I want to change something, I could say, for example, I don't want to know the full name, I want to know the first name, for example. And that is now made a bit more difficult because I can't, if I start changing something here, I'm basically manipulating the original data, which is something you shouldn't do. You should always try to keep the original data intact and then do some process on that from there. So now I put that somewhere, and it's actually here. And I will, where do I upload that now? Okay, maybe that is now too complicated to actually give that to you in an easy way. But I can upload it into this Jupyter notebook. That's a bit complicated. They don't have that one library installed. That is very unfortunate. All right, but I can show you basically how you would do it if you have it installed. This is this nice notebook here. So I'm doing read Excel, and here the Excel library is installed, so I can actually do it. And this data frame will show up in a second. It downloads it and then reads it in, and is now basically just a long table. And now I can start working with it. So I'm only interested in billionaires in the year 2014. So with this command, I select only the billionaires in the year 2014. So I say, in the data frame, give me only the rows that have where the year is 2014. That is now like a smaller data set, a subset of the data. And then I can look at, for example, what country codes are in there. So these are the top 10 billionaires so the top 10 countries where billionaires come from in the year 2014. So the US, China, Russia, Germany. And something interesting I found was actually that if you go to type of wealth, so why are they wealthy, the billionaires, and you say executive, and you count by country code, Italy is in third place. So 7 billionaires in 2014, it's like there's something going on here because, I mean, Italy, the population is lower than in Germany, but they have more executive billionaires. So maybe it's easier to become a billionaire in Italy when you're an executive, question mark. You know, it's not a proof, it's basically just a hint for a possible investigation. And you can also, of course, narrow it down on a specific country. So if we say, okay, we are now really interested in the Italian in the Italian billionaires. So I can ask, okay, country code. So that's ITA. So these are the billionaires. So who's Italian here in the room? Okay, so do you recognize these people? And here's like some more information about them. And for example, when you can now, okay, so how many of them? So where the gender, let's count the gender, and like 3 are female and 32 are male. And yeah, so there's not a real gender balance here. And you can do all kinds of things. So for example, these are the top billionaires in the 2014 data set, where I sorted the values by the net worth in billion US dollars. And so how I usually work with my colleagues is they ask me questions, and they basically ask me questions like, who are the top 10 richest people in the world? And then I create something like this. I tell them, okay, I'll sort the values. I select the name and the net worth. And then I present them with a table like this. Okay, so, but this is not the top 10, so let's do a top 10. And basically, these are the top 10. And this is how billionaires, you know, how it has risen over the years. 1996, around like 400 to 500, then around 600 in 2001. And in 2014, we have 1,600 billionaires in the world. That is like quite an increase over the last, over these like 14 years. And this is basically by gender. There's female, male, and apparently there's also in data set married couple. So when a couple owns the billions. And when I want to know, okay, I want to know, so which first name, how are the first names distributed in the billionaires? I can now start to transform the data. For example, in this case, I'm taking the name, I'm splitting it up by by spaces, and then I take the first bit, and that produces me this list, and it tells me, aha, John is the most common billionaire name. So if you're named John, maybe it's more likely that you will be a billionaire. No, that's probably a wrong conclusion, but you can see where I'm getting at. Yes, and okay, this I think didn't work, but this is basically how we work. This is like a very, very simple example in this case, but it's very effective at transforming data in a reproducible manner and also answering questions that you might have. And when you go back in a year and look at your investigation, you can see, okay, these are the questions, this is what I answered, and you can maybe detect flaws here. Oh, I should have not, you know, done ascending false, I should have done ascending true, because I wanted the tiniest billionaires. But in this case, it's of course not true. I wanted the biggest billionaires. And or you can update the data. So now I've selected 2014. When I get updated data, I can put the new data in and change the year to 2016, and then get better data, like more up-to-date data. But I can run the same analysis, answer the same questions with no effort. And this is basically what you gain, the big benefit from this approach. And I can show you how something like this looks like in the real world. This is an investigation we did at Correctiv. It's about observational studies. So when the pharma industry pays doctors to prescribe certain kinds of medicine. It's a bit simplified, but in the end, pharma companies want to do studies on patients, and they give doctors, okay, if you prescribe that medicine and fill out this form for this patient, we'll give you $600 per patient. And it's claimed to be a study, but it's also the other side. We see it basically as legalized corruption in the healthcare system in Germany, where the pharma industry can basically push certain drugs into the market or sustain them in the market by paying doctors to actually prescribe that kind of medicine. So what we got is basically a list of this data set, so these studies. And so this is basically how it looks like. So it's a bit more verbose, it's more complicated, it's a bit more code, but it's basically the same approach. And if you get familiar with like the simpler variant, like just reading an Excel sheet and sorting it, selecting a couple of rows, and looking at value counts, then at some point you can also work in a more complex environment. So in this case, we had like 2 Excel files, you can see here, with different date ranges in them. And so instead of reading each individual Excel file in and doing some processing on that, I wrote a function here that basically reads all of these Excel files with all of the years in at once and transforms them to something. And this is basically what it transforms them to, a long table of studies with their dates and how many doctors were involved, how much money they were paid per patient, how many patients were in each study. And this is basically a long list of cleaning the data. This data set was very dirty. In comparison, this data set is very, very clean. I mean, it comes from some scientists here, and they provide the data here as a zip file. And so it's super clean. The data has so for example, the country is our country codes. But what I noticed is they made at least one mistake where something is a bit not super clean, and I'm going to show it to you in this example. Here, the name, there's an A. Gerald Perencino and then A. Gerald Perencino. So when you group by name, when you want to see how people over time have developed their wealth, these wouldn't be matched together. So this is basically a mistake in the data. And you can fix this with like a little command here in this notebook. And so when they release a new data set, you will not have to fix the same mistake twice. Another advantage here. And so this is, again, the observational studies. And it's a lot of cleaning. For example, here it's cleaning money values. They are like commas and dots, thousand separators, decimal separators. It's what you need to differentiate when you want a real number. And for example, here as well, we take lots of strings like circa and maximum, max dot out of these tables, so we can have work with numbers and not with something else they wrote in there. So in the end, it cleans basically strings like this: 25 patients to 25, 23,000 patients to 23,000, or removes these spaces, or removes other comments that have made it somehow into this data set, into like real numbers you can sum up, you can aggregate, you can take an average of. And then you can, so this was the data cleaning part, already like a big part of the notebook, but then you can start with the analysis, and you can find for example, the number of patients that is in the data set, the number of doctors, the fee per patient, the mean fee per patient was 500 euros, for example. How many of these observational studies were there over the years? How did that develop? Yes, you can also put plots in these notebooks, which is quite handy, because sometimes you don't want a table. A table is very tedious to work with. I mean, you could look at this and see, this is how it's developing, but when you plot it, it's a bit more meaningful to your brain. And so this continues on, and we will further develop this notebook as we continue the investigation. As we get new data, we will load it in, and basically we don't have to reapply all the steps we did before to get to the results. We just need to update the notebook once. Yeah, this is basically my case for using these reproducible ways in data journalism. And so my favorite part of this transparent and reproducible data journalism is basically that not only the benefits I already described, but this is also, I can learn from others. And you can learn from me, but I can also learn from others. There are many journalists now that use these notebooks, especially in the US. It's now more common in science. when there's like a new cool algorithm that does something, it's probably already been shown in such a notebook, so you can also use it for your own work. And I really like this new type of journalism. You know, before it was very much about elbows, you know, who gets the scoop and who, you know, is, you know, has the better sources. And with this kind of journalism, you know, the data might be already there. You know, open data, you can download it from your government, you can get it through an FOI portal. But then it's about the analysis, and with that you can make a difference, and it's basically then more about the brains, and you can apply it to the data set. But you can also share it, and I don't think you lose much of an edge, or like the competition is not so much there. It's about like the idea for the story and not so much how you write the algorithm in the end. So right now it's, I think, a good thing that is very much encouraged in this new data journalism community to share the results. So in the end, impact of your story matters more than the elbows you use. And actually, that's all I have for you today. I hope I convinced you to try this out in your next data analysis. Thank you. Do you have any questions? Oh, the microphone, the microphone.
Thanks. You mentioned the importance of reliability when it comes to data in general. And I was wondering, sometimes it's very often sometimes you have no time to write something and you need to find data to back up what you're writing. What's your suggestion? I mean, I guess one could do a sort of a systematic review of the literature to see what's everything that's been published in something and try to understand what's more reliable, but that's not always possible. And I guess not everyone has the tools to understand which data is more reliable and which is less reliable. So as a data journalist, do you have any advice on how to select the best data when you have no time to study your own data?
So I worked with the luxury that I always have at least like a couple of days for these projects. But yes, so if you work in a newsroom where it's like a bit faster paced, what I hear, you develop routines, right? There are like reliable data sources. For example, in Germany, it would be the statistical office, the Federal Statistical Office. If you want something, I don't know, about your population and a certain trait of that. You know, there's like a reliable data source. They provided in that format, and then you can also quickly get from the raw data that they provide you to what you need to know. And so if you've done this like 2 or 3 times, and you already have you know some code or some knowledge about it, you can work more quickly. For more specialized data sets, or like data in general, so these studies, it's difficult. You know, it's if you rush things, I mean, you need to be careful with the studies. I mean, study analysis. So if you look at a study and have to decide if it's like proper, how they did it, it's easy to miss something, and sometimes they also try to hide their methodology. There's p-hacking going on or something that they're trying to like give you the best result they could come up with. And if you want to try to counter that somehow, more time is definitely always a good thing, because it's tough. So more routine, and try to fight for more time. Data journalism is not something, it's hard to integrate into the newsroom. As I showed you the data cleaning and the data analysis, I basically left out the part where you actually publish. And this is more difficult. So for publishing, you need a fancy graphic. And I can do the cleaning and the analysis in a reproducible way in there. But the step to actually going online with a nice graphic, that's harder. I can produce these little charts that are basically just for me, that are sketching how I went from A to B, or how this a line develops. But you hardly ever take that chart and put it online, because it's not pretty. It's not the style guide you use. It doesn't use the right colors. And getting out of these notebooks into a publishing process is more difficult. So there's most of the time there's still like manual steps involved, like using InDesign to make the chart nicer and stuff. And this is still something I think many people are trying to work on right now to make that process smoother. There are certain integrations you can use to basically go from data to chart. But as soon as you do some customizations, this also goes out of the window. And yeah, so this is still like an unsolved problem. Data journalism is quite young, and so the publishing pipeline is not finished by far. Any other questions?
Hi. Yeah, the tools that you've shown us seems very interesting, and it looks like they're really used by, for instance, the company that you're working with. But I was wondering, like, how common are these tools, and how, like, is a lot of these data shared also among bigger companies, like bigger sort of like news groups and newspapers, or is something that for the moment is for more sort of like smaller independent news companies?
So especially the notebooks I've shown, they are quite popular, especially also among scientists, because reproducibility is traditionally something that science does. If you do like an experiment and write about it, basically with the scientific community, the task is that someone else does the same experiment and can verify the results. So they have to be reproducible, so they, that they are actually through reproducibility, you gain basically scientific knowledge. And I think the same thing should apply to journalism, more or less. I mean, we are not scientists, we make stories, not scientific knowledge, but there are links between them. And I think in Europe, there are still few news organizations that use this and also publish their methodologies in that way. But in the US, it's actually quite common. So 538, Vox.com, Quartz, all these like younger but still very big media corporations have repositories on the site called github.com where they share code and data from their stories. Also, I think the New York Times does that as well. Not for all the stories, but for example, and they do election analysis, for example. And it's quite interesting to look at these repositories of these media organizations and look at how they do things. This is actually something where I learn a lot from, how they approach their analysis, how they approach their investigations. And as soon as you learn from these things and you do a story, you should basically share also your methodology. So I don't know, it's a good trend, I think. It's not something we should be afraid of, and I think it's something we should embrace actually here.
Thanks. Hi, back here. I'm not going to stand up because I have my laptop. If you had a team of software engineers that were just kind of at your disposal after all the tools that you've played around with, what would you like them to do to make either these tools more useful or something else that would make the overall job of reproducibility and transparency better?
Yeah, so there are, I think, a couple of things. So off the top of my head, it's possibly that the integration of these Jupyter notebooks with the publishing workflow of a news organization. So that between your analysis and cleaning to something on your website that you can show other people, and maybe even link back. That might be nice. So you don't only want like a static chart, you may want like more of an interactive graphic. And there are already some tools that try to do that, but none of them still already have it like nailed down. And refining that and maybe also integrating it with like a CMS, like a content management system, might be nice. And then there's already like lots of progress. The libraries around these projects are always updated. What I'm actually trying right now, I tried to finish it for this conference, but I didn't manage to do it, was Correctiv has a membership system. So we have members that pay us something every month, and they get like some special goodies for that. And that's basically how our organization is financed as a nonprofit. And what I want to do is I want to give these members access to computational environments of our data analysis. So they can click on a link, and then a notebook opens up with our analysis, and they can run the analysis themselves, and they can play around with it. And this has already been done, I think, by some scientific magazine as an experiment, and I think it has been very successful. So that you could like play around with the data, get your own perspective on it. I mean, it's not something for the general masses. I think it's more for like a bit more nerdy and niche thing. But it shows that you have like confidence in your analysis, and that you are very transparent about your motives. And giving that to more people might actually be quite nice. And how to do that, how to scale that, because right now there are a lot of cheap things like space, so like hard drive space, storage space in the internet is very cheap, but CPU time is still a bit more expensive, so giving others like a computational environment where they can compute things is, I mean, it's also getting cheaper, but like providing that to everyone is still, yeah, I don't know, a bit more difficult. And yeah, working on that might also be interesting.
Can you expand a bit on the difference between a data scientist and a data journalist, and how the two should work together to produce data like this?
Yes, so a data scientist, I think that's a new term for a statistician, more or less. So a statistician that works with, I don't know, modern data or something. And a data journalist, I mean, the data journalist looks, a data scientist more looks for, let's say, correlations and how to explain them, or how to, it's more of an analysis thing, and then writing like a paper. Or the problem is many data scientists right now work in the advertisement industry and try to improve, I don't know, a conversion funnel, so to make someone buy something. The data journalist has this nice journalist in there, which is like the motive that we all share, I think, you know, writing a good story that has impact, that improves people's lives. And it's basically, I think the data journalism is like a data scientist with a journalistic motive, possibly, that uses the same tools, the same methodologies, but basically then uses the means of the method of a story to produce an impact, to change something for the better in the best case. So maybe that might be a nice definition. I'm not no authority on that, but I could see that as an explanation. Okay, any other stories? Questions?
Hi, I come from the data visualization side of things, so I'm interested to see, you mentioned a couple of tools like R, Python, there's some others that designers use to jump into data design. And I was thinking a lot of the things you said about those little graphics that you managed to create with the software you demoed, but you use them for yourself. You don't necessarily have the time to do fancy graphics or interactives. So do you think, if time allows, in the work you do and your organization, would you see a benefit of these two figures working together more and more to create something that can be explored and used?
Definitely, definitely. So there are also already a couple of libraries, like Bouquet is one, or plot.ly, Plotly. They have integrations with these notebooks where you can like use your data frame that you have like transformed in some way, and then say plot, and then it generates this web-ready version of a chart that's a bit more interactive, where you, I don't know, have like labels that when you hover and stuff like that. But you can still, it's like still like there is still some uncanny valley until you can put this into like a website, into like a bigger production. And ideally, if you change your data set, it would like update itself on the website. But yes, so there's still this gap. I mean, even the New York Times, that is always cited as like it's like very nice graphics. They use InDesign a lot to refine them, and use like this InDesign to HTML export to and actually put it on the web. which makes it always like a bit more complicated process that is like a bit more difficult to automate. But in order to produce like the best result right now, it's apparently one of the solutions. And but I can totally see that this is going to work better together in the future. And it's important. So what we do right now is we do the data analysis, export to CSV, and then build like a D3 visualization that loads that CSV. But we have to basically rewrite the charting that we want in a more fancy way, in a more complex way for the browser. And yeah, so this is still a mismatch, but I think we are getting there. We're getting there. Any other questions? Well, no. So thank you. And if you have more questions, I'll be around, so talk to me.